Uploaded this lecture on Canvas, and I hope you can see it here on my screen now. So before moving to this lecture, let me give you a little bit explanation about multimedia traffic. So multimedia traffic is a bit different from normal traffic. Multimedia traffic is a bit heavier as compared to your normal traffic. In multimedia traffic, we have images, or you can say pictures. We have audio, music. We have video. And you can also say like the MMS services. So as compared to normal data, multimedia traffic is heavy and therefore need more system resources. So this is about multimedia traffic. That's why we focus on, we can take special note of multimedia system. I have lecture over here. So here are the course objectives. You can see over here what is multimedia, the data compression techniques, and a requirement of multimedia kernels. Similarly, we have the CPU scheduling, the desk scheduling, and the network management. So what is multimedia? As I told you earlier that the multimedia traffic is a bit different from normal data. This data include pictures, high resolution images, audio, and video clips, and the file extensions or the file types can be like MP3, like MPG, like JPG. You can also have the live webcast or the live broadcasting of any meeting, like we have now this live broadcast in this class. The multimedia data may be delivered to different sources as well. And the main purpose of explaining this point is that sometimes the capabilities of these devices may vary. One device may be able to receive data with faster pace, it has more processing power, it has more memory, or it has more bandwidth. But there may be some devices which don't have enough bandwidth for live webcast. So you can see that there may be a desktop computer, which means that computer is properly connected with the internet connection, or you can say an internet connection with some tangible media. while you also have the handheld devices like your smartphones and the PDAs, which are mostly connected with the Wi-Fi network, or you can say with the cellular network. Now here is the introduction of distributed multimedia system, which is an integrated computing, communication and information system which enables the processing. Now you can see over here, processing was also there, the management, the delivery, and delivery must be without any error. And similarly, the presentation of synchronized multimedia information with quality of service guarantees. So look at this as the two systems, the sender and receivers are synced with one another, and the system also ensure that there should be no error, or there should be the same sequence of data in which it is sent. As we already discussed this example over here, that in such systems, it is guaranteed that you have here 3 packets or 5 packets, 1, 2, 3, 4, and 5. Number one, you transfer this data from source to destination, and this is the source. So look at this. The first thing is that data is delivered. Data delivered. Now, number two is data delivered without errors. And number three is data delivered in same sequence sent by sender nodes. And number four may be data securely delivered without any modification. Without any modification, data is delivered from source to destination. So that's why it is important that sender and receiver must be synchronized, and the system should provide the required quality of service. Now, there are many characteristics of a distributed multimedia system. Number one is that it should ensure the delivery of streams of multimedia. As I told you, that there may be streams of audio messages, there may be streams of video messages. So you can have different types of stream, and you should ensure that no data should be missed in that stream. Similarly, most of the multimedia communication is real time, and that's why your data delivery should meet the requirement of time at which data is required at the receiver side. So that's why the DMS system characteristic is that it should provide the required quality of service. So look at this, required quality of service is that some video may require 100 frames per second, some may require 20 frames, some may require 50 frames. So the system actually adjusts itself and provide the required quality of service. Similarly, there is flexibility that the system may adapt itself as per user need. And as I told you that it is not always the system, but the receiver may not be able to receive with the same speed. The transmitter, the sender may not be able. For example, here we can say that this sender can send 100 packets per second, while this receiver can receive 50 packets per second. So look at this. The remaining 50 packets will stay here on the link, and it will cause congestion on the network. Congestion on the network. So that's why we must ensure that he should reduce the system or the sender speed to 50 packets per second. And that is, so similarly, over here you can also reverse this example, that the receiver node is able to receive 100 packet, but the sender is only sending 50 packets per second. So over here there is possibility of a different scenario, possibility of different scenarios. So either the receiver is not able or the sender is not able to receive or to get or to send with the same pace. Similarly, we also have the availability parameters and excuse me, yeah. Similarly, we also have the availability parameter, that the system is available whenever it is required. And the scalability parameter, that adding or dropping of new nodes may not affect the performance, or you can say the overall performance of the system. So that is really very important, that the system should not fluctuate whenever any new node join the system or join the network, or any node leave the network because of some failure. Here we can see different factors that can affect the performance of the system. Number one is the server bandwidth, and it actually means that how much system a server can accommodate at a single time. For example, you can see over here we have a server here, and it can accommodate 100 computer or 100 PCs at a time. Though we have 500 computer or 500 systems here. So always the remaining 400 PC will be in the waiting state. So for example, if all the 500 computer want to communicate with the server at the same time, at the same time, then 400 computer will always be in the waiting state. And over here you can see in the next slide, cache space. So this is not only the bandwidth, but also the hardware and the software capabilities of the system, that how much space, how much bandwidth they can provide to the number of users, or how many nodes they can handle at the same time. Similarly, number of copies they should send at the time, then the number of clients they can handle at the same time. So for example, if the system is actually able to entertain 100 PCs at that time, so it means this system is at bottleneck, and any failure, it may any failure can destroy all programs in execution. So any failure in this system will cause the failure of these 100 programs. So that's why it is important that you can check that how many users or how many clients can be accommodated per server. In this slide, you can see that we have a typical infrastructure component for multimedia application. There are different components you can see over here. First of all, you can see you have different type of traffic. You have a camera which carry images or which carry the video information or data. Similarly, the microphone will carry the audio data, and similarly the screen will also carry the images and the video data. So here you can see that we have codecs. It's a two-way communication. We have the codec and there is a mixture. So the microphone actually combine these video or picture with with this audio. And then onward on the other side, you can see over here that they have the screen on which they can watch any picture or any video. Similarly, they have the mic on which they can listen the audio signal, and similarly they also have the storage here where they can store the video or multimedia data. There are three type of network connection: K, L, and M, and because of different options, they can communicate with one another. Over here, you can see that the white boxes represent media processing component, many of which are implemented in software. And as I told you, that these are a kind of software defined architecture. You can see the codec which do the coding and decoding of these audio, these pictures and video messages, and do the necessary filtration. And similarly, the mixer is responsible for mixing of sound component with the data. Here in this table, you can see the characteristic of a multimedia stream through different technologies. For example, you can see the telephone speech, and the data rate is 16 kbps, and the sample size is 8 bits, and the frequency is 8,000 per second. Similarly, you can see for the CD quality sound, as we have the DVDs. Similarly, for the standard TV video, you can see he also mentioned that this is uncompressed. Uncompressed means there are still free spaces over here. You can see the sample size and the frequency. Similarly, we also have a standard TV video that is MPG compressed, and you can also see the data rate is higher, and the sample size is variable. You can also see the high definition TV, HD TV video, and uncompressed and compressed. And over here you can see the frequency and the sample size is variable. Though the data rate is increased from 64 kbps to 10 to 30 mbps. Media delivery in multimedia data is stored in the file system like other ordinary data. However, multimedia data must be accessed with specific timing requirement. And let me explain over here that how multimedia data is stored. For example, this is a disk, and this disk is divided into tracks. As we already discussed this earlier, these are tracks. So you can see over here, this is a track, and further you can divide these tracks into sectors. So this part of a track is called sector. So in normal data, for example, there are multiple disks, you can specify the disk number. Similarly, you can specify the track number, and further you can specify the sector number. So you can have the address over here. In case of simple data, it can be stored anywhere. Randomly, anywhere in memory. You can store it anywhere inside the memory, but over here, the multimedia traffic is in streams. So you should save the multimedia traffic in continuation from one sector to another sector. So for example, if the head, this is the head, we start reading, and this is the disk which revolve under this head. So for example, if it's a multimedia traffic, it should be in the form of stream, and the head continuously access in the form of stream. For example, if you are saving it some part here, you are saving some part here, then the head will actually jump over here, or the disk will revolve around to access this portion and retrieve the data from here. So that's why in multimedia system, it is necessary to save data at one place. So the head should not jump. The head should not request. You can say request or search for new addresses again and again. So this is important. And for example, if the head is searching again and again, then it means it will affect the performance, affect the efficiency, and performance of the system. So this is important that, for example, let me draw a grid over here, and then you can see that if I want to access anything, then it will be easy. One example is that this one, and the other is this one. So look at this, I write it in continuation like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18, 19, 20, 20. This is one way in continuation, and one is random. Like for example, here you can write 1, then you can write 2 here, then 3 here, then 4 here, then 5 here, then 6 here, then 7 here, then 8 here, and 9 here, then 10 here, 11 here, 12 here, 13 here, 14 here, 15 here, 16, 17, 18, 19, and 20. So look at this, the search operation or the accessibility operation is very difficult. For example, you reach here to 1, then you will search all these cells to access this 2, then again you will start searching and will to access this 3. While over here you can see that you will start in continuation in a stream and will read this, then we'll start here and we'll read this, and then we'll start here and we'll read this. But over here, more addressing and more jumping by the control is involved. While here it is in continuous sequence that you can easily access your required data from this disk. So that's why it is very important that how your data is stored. For example, he is giving this example over here that video must be displayed at 24 to 30 frames per second. Multimedia video data must be delivered at a rate which guarantee 24 to 30 frames per second. So here you can see that you must provide these frames per second, and it will be very easy for the system to, if you store this data in a sequence without storage of data randomly, because random storage will definitely make it more complex and more uh, time consuming for the sender node to find this data and then transfer it to the receiver node. So look at this. You can see here the last point that continuous media data is data with specific rate requirement, and this rate may vary from system to system. Over here you can see the multimedia traffic over here, the video file, the video frames are here. There are 8 frames. So look at this, on each frame, these two people are getting together with one another. Here you can see there is an English audio, you can play with this video, and the speed should match with each other. Otherwise, if the action will be different from the words. Similarly, there is also French audio, there is also German audio, and you can also add subtitles in Dutch as well as in English. Similarly, what will be the speed? If you fast forward, then how many frames will pass per second? If you fast backward, then how many frames will move back? So look at this. This is a complete structure of a video file with the recording of English, German language, and French language. And similarly, you can also have subtitles in English or in Dutch as well. So every user will select as per his requirement, and the system will adjust accordingly. So look at this, you just select that I want to see French, I want to listen French audio with Dutch subtitle. So the system will adjust accordingly as per your requirement. Simply you press fast forward. So you can also see in many multimedia player, it is visible. For example, if you want to fast forward a movie over here, and the frames are given over here, and it also tell you that how many frames you want to forward in a second. Either it is 2x, either it is 4x, either it is 16x, Either it is 32x or it is 64x. And in many other, there is even 128x as well. So it means you will forward 128 frames per second if you press this fast forward with 128x. Or similarly, you can also have the 2x, you can also have the 4x, but it totally depends on the user requirement. Depends on user requirement, that how much the user wants to, how much the user want to forward. Here, what is streaming technology? Now over here you can see the streaming technology, a technique for transferring data such that it can be processed as a steady and continuous stream, and client doesn't have to download the entire file to view it. So you can see over here that you are receiving data, and at the same time the system will play. You have already watched the live matches on TV, and at that time the data doesn't store on your local computer. You watch that game at that time, and the frames are coming and buffered for some time in your system memory, and then onward transfer to the multimedia player. Here you can see the data is transferred from source on the network, and over here you can see the blue portion is the portion in the buffer. Similarly, the portion client is viewing is this one, and next is actually that the client already viewed over here. So there are three things. One is that was processed, watched by the user. The next one is currently playing, and number three is that the data which is buffered are prepared to display on the screen for the user. And the fourth is the data on the link which is coming and will be delivered to the user as it is received. There are two different types of streaming. Number one is progressive streaming. The client begins playback of the multimedia file as it is delivered. The file is ultimately stored on the client computer. And you can also see that there are many videos, especially in terms of WhatsApp. WhatsApp, every video you watch will be downloaded to your device. So it consumes a lot of space on your mobile phone, on your computer, wherever you watch that video on the WhatsApp application. While the other is real-time streaming, where the multimedia file is delivered to but not stored on the client computer. And these are the video you can watch on the Facebook, that it can play, you can play the video, but it will not store to your system. Similarly, you can watch the video on YouTube, on Dailymotion, or any other website that doesn't download that video to your system. But there are even certain requirement of few videos that you should install this player, then you would be able to run this video. And for that purpose, if you are not installing the video, but you are installing the app for that specific video you want to play. There are two types of real-time streaming. Number one is live streaming, that is used to deliver a live event while it is occurring. As I told you that when you want to watch a rugby game, you want to watch a soccer, or baseball, a football, a basketball game that is actually occurring at that event, and you have live streaming from there. Similarly, on-demand streaming is used to deliver media streams such as movies. So actually on-demand streaming is from a storage, from a server. For example, if you are going to search a movie, then you may have different options. You can search from the US server, you can search from the French server, you can search, you can access our, you can watch from the Canadian server, and then onward the other parameters such as charges, such as security, such as speed, such as performance, such as comments of the users are also given about that server. So here you can see that the events are not occurring in real time, but these are stored somewhere and you want to access. The forms of streaming media is a pre-stored media which is already been recorded and archived somewhere. When the user want to access it, we serve it as a stream. Something is stored over here. For example, we can store our lectures on the canvas, and whenever you want to, you can access it as per your requirement. Similarly, live broadcast media is the content is streamed as it's produced. There may be a small editing safety delay as with traditional broadcasting, and that is straight to the user. Nowadays, the straight to the user is a bit dangerous because there may be some mishap, there may be some unintentional actions or some unintentional speech that the user don't want to, and if you straight send it to the user, then everything is means listening or watching by the user. That's why there is a buffer zone where you actually polish the stream of data or the movie or the video or the television program, and remove the unwanted messages, the unwanted video actions that was already recorded. Live interactive media such as video conferencing, each user might produce their own stream, and that is not controlled by one broadcaster. So it means everyone is free and they can have access to other user, and they can also provide their own multimedia stream to other user. Here are certain advantages. You can see that this streaming actually reduces the download time. It provides steady service, continuous service is there. Slower system can take advantage of streaming technology as well. If some systems are slower, then they can save data, and whenever the multimedia player is free or available, it will be delivered to that data. It also provides service on demand to the user. Applications are utilizing this technology, such as streaming video, IP telephony, which is nowadays very common, the internet radio, the distance learning. This is actually the class we are taking is some sort of distance learning, and video conferencing and interactive games, which are very common these days on social media. Most of the people are playing these games and they are live with one another. In disadvantages, he's saying that it is difficult to keep the service steady if the bandwidth is low. And we are facing these problems in many areas, even somewhere in the university as well, where the signal is very weak, especially the Wi-Fi signal. So if you are in that area on campus, then you may not be able to have the required bandwidth. The maintenance of streaming server is relatively also very expensive, that you have to maintain all the records from where you got data and where you will send it, or what is that, how much frames you will receive, what is the requirement of the user. The packet loss may occur due to extensive packet transmissions. So the reason is that the packet may collide with one another, and then you will lose your data on the network. Multimedia system characteristics are here that the multimedia files can be quite large, and as you have seen that these files are in GBs, Even some are with very high qualities may reach to the terabytes, and further you can access to zettabyte to petabytes. Continuous media data may require very high data rates, and multimedia application may be very sensitive to timing delay as well. So for example, if there is any delay, you would not be able to listen the voice or to watch the video in that particular span of time. And all the resources reserved for that particular purpose would be in waiting state. Here in this slide, you can see that you are accessing audio and video through a web server. So here the web server is getting the file and send it to the multimedia. The web server access these files through HTTP protocol from web server. The web browser, you can see if you don't have the web browser, you would not be able to surf the internet. You have specified web browser, like you have the Internet Explorer, you have Google Chrome, you have Opera, you have Mozilla, and there are many more. There are many more. So if you don't have the required web browser, you may not be able to use the web services. Here in this slide, you can see that a meta file is used to access the web services securely. In web browser, you can see the connection is established through HTTP request and response for meta file. And then the meta file is transferred over here and is transferred to multimedia player. And then the meta file by itself start a connection process through HTTP protocol with the web server and request for audio and video files, which is sent through HTTP. Now, instead of web browser, you can see the multimedia player is directly communicating with the web browser. A meta file contains information of URL, the type of encoding, etc. about the audio and video file that is to be streamed. And as I told you, while you are watching for or searching for video, there is a requirement that you should install Adobe Multimedia Player before watching this video. It is further explained here in this diagram, where you can see the first one is client, the client, and web browser and web server. And the client request to the web browser, web server for the client web browser requested to web server for meta file. The meta file is transferred here in second step, and then onward the meta file actually provide access to the multimedia player, where multimedia player directly establish its connection through HTTP with the server, and then onward the servers start the media streaming or the media processing or the media stream transferring to the required client. Here is the RTSP diagram, that is real time, where web browser again requests for meta file, and meta file is transferred to multimedia player, and then the multimedia player actually is responsible to provide RTSP real time streaming protocol command, where data is transferred from streaming server to the media player. You can see over here they have now separated the web browser, the web server from streaming server, and the streaming server over here on delivery side use the RTP real-time protocol, which is used for real-time communication, and similarly RTP video content as well. HTTP is insufficient for user interaction with streaming server. Therefore, you can use the RTSP and RTP. With streaming server, audio and video file can be sent over UDP as well. As you know, the UDP protocol is also considered as a fast protocol, but it don't try or it don't care about the security and the quality of service. So here in this diagram, there are three steps involved. In first step, you can see the client web browser request for web server services. Similarly, in two, you can see the description file is sent over here. That is, as we discussed earlier, the client file, and then onward it is transferred over here. This is actually over here the meta file, and then onward the media player is able to access data or requested data from streaming server, and all this process take place through internet. In real time streaming protocol is, I told you, RTSP, where web browser request to web server through HTTP for meta file. The meta file is transferred over here, and then the meta file actually provide access to multimedia player that it can directly request to the server. So here the RTSP is used, the real-time streaming protocol is used over here between multimedia player and server. And then onward, the media stream is transferred back to the client multimedia player. There are certain protocols used for this streaming technology, and you can see over here there are 5 protocols. The first one is SDP, Session Description Protocol. The second one is Real-Time Transport Protocol, that is RTP, a Transport Layer Protocol, and Real-Time Control Protocol, RTCP. And similarly, the fourth one here you can see is the HTTP Hypertext Transfer Protocol, and real-time RTSP, real-time streaming protocol. These are 5 protocols which we will discuss. The important one over here. The real-time streaming protocol is industry standard internet application level protocol, where this TSP is a framework for delivering and transmission of multicast data stream, that you are actually delivering data to multiple points, not to a single point. The RTSP allows a media player to control the transmission of a media stream for exchanging control information. And in another important function of this RTSP is its ability to choose the optimum delivery channel to the client. So this is the last point is very important, that if even multiple channels are available, then it doesn't make this decision in hurry, but it actually compare all the available channels and select the optimal or the optimum channel that is best at that time for data delivery. The RTSP features are given here on this slide, where this protocol works in conjunction with RTP. As we discussed, this RTSP is the application layer and RTP is transport layer protocol. So therefore, RTP is used to deliver streaming audio and video content. The standard HTTP is stateless. We already had discussion about stateful and stateless. So this is stateless, whereby the server doesn't maintain the status of its connection with the client. RTSP maintain a server state during transmission, and the limitation in client server architecture is that it overcome the limitation of HTTP. HTTP limitation is this one, that it is stateless, while the RTSP is a stateful protocol. RTSP enhance HTTP function as well by saving the state information. RTSP provides the synchronization of the event as well. So this is also a very important parameter that is handled from application layer protocol in case of HTTP. Here are 4 states of this RTSP protocol. The first one is setup, that is used to set up the connection between client and server. The server allocate resources for a client session, and then onward. Next is play state, where the server deliver a stream to a client session. The client is uh, is very important to play any stream of data. Similarly, the pass state is also there, where the server can suspend the delivery of that particular stream for any user. And the fourth one is tear down, that you want to tear down the connection. Either you have received all the data which was required by the client, or the server break down the connection and release the resources allocated for that particular session. You can see here the state machine is initiate, then setup, then the system is ready, then you can play, then the media data is transferred and you can play the multimedia data, then you can pause and will come back to ready, and from ready you can jump back to the playing. Similarly, in once you have watched all the required data, then you can tear down the connection and then approach to the initial position. Here is the RTSP operation. You can see over here where the web browser, as we discussed in last slide as well, HTTP GET operation, our function is used over here through HTTP, and then the web server responded and present the description file. That was meta file earlier we discussed. Then through meta file, the multimedia player establish a connection with the multimedia player over here. And then onward, it start playing uh, the required or the requested video or audio file. Look at this, the RTSP protocol is used here between these two multimedia player for communication. The media player is continue. Look at this, you can pause this connection anytime the server wants or the user want. And over here, once the data is delivered, you have watched the video, then you can request for the tear down of this connection. Here he has discussed this in sequential form. RTSP media player server sequence chart. You can see this is the user interface, the RTSP player and the RTSP server. So the user actually send the URL, open the URL of RTSP player, that is the multimedia player, and then the multimedia player actually established this connection with the server. Once it responds back, then you can see here is this sign of multimedia player. Now you can play this audio or video. And once you click the play button, you will send the play command to the server, and the server will activate the RTP protocol, and you will get the audio or the video that you have requested. Over here, you can pause this video and the response will be forwarded to the server. So it means you are directly using this data on the server. You can play it, you can pause it, you can tear down the connection with the last operation. You can see over here, once you quit, then the player actually transfer your request to the to the server of that particular activity. The next is RTP protocol, where RTP is used to transmit real-time data, and the RTP encapsulate segments. So this is again the encapsulation process we already discussed in OSI model on different layer. And you can see the packet or segment of this RTP protocol. You have the payload type, you have the sequence number, the timestamp, when the data was actually initiated or started over here, then the synchronization source identifier, and you also have some miscellaneous points over here. Here he has given the comparison of RTSP and RTP, it is important to distinguish between RTP and real-time streaming protocol, which is another transfer protocol. Or over here in the next line, you can see that RTSP is used when viewer communicate with a unicast server. Look at this, RTSP is used. RTSP allow two-way communication, that is, viewer can communicate with the streaming server and do things like rewind the movie, go to a chapter, and so on. For example, if you are listening the video of this lecture and it is stored on the canvas and you want to revise, so that is a kind of one-to-one communication, and you can revise, and then the protocol that will be used here in this situation will be the RTSP protocol. QuickTime automatically translate the viewer interaction with the on-screen. You know, QuickTime is actually a multimedia player, and he is saying about that player on screen movie controller into the proper RTSP request. By contrast, RTP is a one-way protocol which is used to send live a store stream from the server to the client. So this is RTP and RTSP difference. Or over here you can see the streaming in mobile environment. Here is your cell phone which is connected to the BTS point, and then BTS point is connected through cable through the actual server or the proxy server. And over here you can see the content creation machine. You have different servers over here, and then the protocols that are used to transfer data from the server to the client. So you can see the protocols over here. In case of streaming, you can see FTP is used, HTTP is used, RTP is used, RTSP is used. And on the transport layer, TCP is used with all these protocols. Similarly, over here in terms of web server, HTTP is used and FTP is used. And the TCP protocol is used with both of them. In standalone content creation machines, you can see the HTTP and the FTP is used over here. And similarly, between this network device, which is a switch or router, and this proxy server, again RTSP, STP, and SDP is used. Here are certain methods that RTSP can use, and every method has a particular function. Once you call this method for execution, then definitely it will perform the same operation. Like method is describe, which retrieve the description of a presentation. Similarly, announce, it posts the description of presentation. Get parameter will retrieve the value of a parameter. Similarly, options, you have the pause, you have play, you have record, you have redirect, you have setup, you have set parameter, and similarly, you also have the connection tear down problem. So these are about the multimedia traffic or data we have discussed, and from where actually the topic change. So I think that will be enough for today's class that we can discuss. And from the data compression section, we will actually start from next lecture. So this is a 51 slides in this lecture, and in next we will discuss about the data compression, and then onward the other issues of the multimedia systems and the operating system. So now if there is any question you can ask about this lecture. So yes, please. If there is any question, you can ask. No question?
I have a question about the review paper and the abstracts. Are we going to get any feedback about the abstracts that we submitted to you? Or if we don't hear anything, can we assume that we can just proceed with our research?
Exactly.
Okay.
Actually, it's taking more time while you are digitally checking all those things. On paper, it is much easier. And you have seen that I have uploaded the marks of quiz 1 and homework, that was assignment 1, on Canvas. So in terms of research paper, on Friday I will show you that how to prepare your presentation, because in next week we have to start our presentation. So you should continue working on it. The next step is your literature review and comparative analysis. And I hope the recommendation and the tool and conclusion is not a big task. But the most important one is the literature review. You should have at least 10 approaches and then compare those 10 approaches against each other. So that is important, that you should continue work on research paper, and hopefully on Friday I will share that how you can prepare the presentation slide wise. I'll show you the slide wise in lecture that how you can prepare presentation. As we discussed that how you can write the paper, similarly we will discuss on this Friday that how you will prepare presentation so you can present it to me in next week. Any other question?
Yeah, just one more. Does that mean our paper has to be finalized before next week, or do we have time next week to
Oh, you will,
revise and finish?
yeah, you will present the paper, and in presentation again, if I can see that some improvement are required, then you will improve it. And you have time till 30th July to complete and finalize your paper. After, I mean, on 29th, if you submit your paper, then I would be able to give you the final marks of your presentation and your research paper. I will mark nothing about research paper and presentation, because it's a continuously improving process. You will submit and I will take you to the next step, and I will identify the problem in the previous step. And as I am after this question and answer session, I am going to explain that there are many mistakes. There are many blunders done by many students, that they have written directly from the slides. They are just going and Google the question of a midterm and quiz, and then copying it from there and then pasting on